So solving for these ones, again, we're going to look at the positive and negative versions. So I need to establish the positive version where the inside is equal to the positive. So the domain of that is going to be when x is less than or equal to 3. And based on that domain, I'm going to have the equation 3 minus x equals negative 2. Okay, so we keep the same sign if it's positive because we want that to come out positive. Solving for this, I get 5 on this side. I add 2 to both sides. I add x to both sides, so I get my answer 5 equals x. And in this case here, it looks like it's extraneous because it is conflicting with our domain. So if you take a look here, if we take a look here, there's between here and here, there's a conflict in the domain. So then we need to establish the negative version of this solution. The domain of the negative version of the solution is going to be when x is greater than 3. And so when it's negative, I take my x minus 3, and it has to equal the opposite because I need to convert that negative into a positive. That equals negative 2. Solving this, I end up with x equals positive 1. So again, when I compare this with my domain, it is outside the domain, so these are both extraneous solutions. Now I can always just check these as well. Okay, so I can always check. So I'm going to check it by substituting in. So I'm going to check my two solutions. I'm going to check x equals 5. It's going to be 3 minus 5 is equal to negative 2. Well, 2 is not equal to negative 2, so this is extraneous. Okay, so we have an extraneous solution here. We can also check x equals 1, and we end up with 3 minus 1 absolute value is equal to negative 2. Well, 2 is not equal to negative 2. So again, this is extraneous, so there's no solution. Now, if we had recognized that an absolute value cannot equal a negative, well, we could have decided at that point that there's no solution to this equation. Okay, so we didn't have to actually do all this if we recognized that at the very beginning. So here we're going to establish our positive solution based on the domain when x is going to be greater than or equal to negative 3 over 2. Okay, that's going to be our positive domain. So we're going to keep the inside positive and then solve this. We end up with x equals negative 1. In this case, x equals negative 1 fits in the domain, so we should have a good solution. The negative domain is going to be when x is less than or equal to negative 3 over 2 or negative 1.5. So we're going to take that 2x plus 3 since it's going to be negative. We need to change it to a positive with that negative there. Okay, so that double negative makes it a positive. We can go ahead and solve this. So I'm going to subtract 2 from both sides, add 2x to both sides, and I end up with a solution, negative 5 over 3. And that solution is consistent with our domain because it's less than negative 1.5. Okay, so we can always test this as well or check our solutions. Our check for x equals negative 1, we're going to end up with negative, it's just going to be 1 is equal to negative 1 plus 2 is going to be 1. That's okay. That's a perfectly good solution. We can check x equals negative 5 over 3. When we do that, this is a little bit more involved, but it's going to give us negative 10 over 3 plus 3, which is negative 1 over 3 on the left-hand side, And negative 5 over 3 plus 2 is plus 6 over 3. So it's going to give us 1/3. Absolute value of negative 1/3 equals 1/3. That's perfectly good as well.